The Science of Electronics, Chapter 2. Scientific and Engineering Notation. Very large and very small numbers are represented with scientific and engineering notation. If you have the number 47 million, which is equal to 4.7 times 10 to the 7th, and it's also the same number as 46 times 10 to the 6th. If you move the decimal place over 1, 2, 3, 4, 5, 6 places, that gives you the engineering notation, and one more place is scientific notation. The difference between engineering and scientific notation is that scientific notation will always have this first number between 1 and 9, and engineering notation is concerned with the exponent. It has to be a multiple of 3. Engineering metric prefixes. These are some of the prefixes with their names and symbols. These are more of the common ones that we will be using. Metric conversions. When converting from a larger unit to a smaller unit, move the decimal point to the right. Remember, a smaller unit means the number must be larger. And I would recommend, after you review this lecture, to look at my other video that explains how to convert these numbers in more detail. These are just some fundamental units. Some important electronics units are current. The unit on current is an ampere. Ampere is an A for amps. Charge is represented by coulombs. Symbol of C for the coulomb. Charge's symbol is Q. Current symbol is I. Voltage symbol is V. Units are volts. V is for the volt also. Resistance is R. The unit is an ohm. The symbol is an ohm, omega. And power is a P. The unit is watts. And the symbol for the watt is a W. Significant digits. When reporting a measured value, one uncertain digit may be retained, but other uncertain digits should be discarded. Normally, this is the same number of digits as in the original measurement. Example, assume two measured quantities are 10.54 and 3.92. If the larger is divided by the smaller, the answer is 2.69, because the answer has the same uncertainty as the original measurement. Rounding numbers is the process of discarding meaningless digits. If the digit dropped is greater than 5, increase the last retained digit by 1. If the digit dropped is less than 5, do not change the last digit retained. If the digit dropped is 5, increase the last retained digit if it makes it even, otherwise do not. This is called the round-even rule. Algebra review. The general equation for a straight line is y is equal to mx plus b. This is called the slope-intercept form of a line. The letters x and y stand for variables. The letter m stands for slope, and it is a measure of how steep the graph of x and y is. A temperature-sensitive resistor is described by the equation R is equal to 1.8 T plus 4. R represents resistance in ohms. T represents the temperature in degrees Celsius. What is the slope? Well, if you compare it with the above equation, y equals mx plus b, the slope is defined by the coefficient in front of the x. In this case, it would be t, so the slope would be 1.8. What does the 4 represent? The 4 represents the y-intercept. To solve the basic equation with a single unknown, isolate the unknown by doing the same arithmetic operation on both sides of the equal sign. For the resistor described by the equation R equals 1.8 T plus 4, what is the temperature when the resistance is 60 ohms? So we need to put a 60 in for R. So our equation becomes 60 is equal to 1.8 times T plus 4. Now we need to isolate, we need to solve for T, so we have to move the 4 to the other side, so we subtract it from both sides. That gives us 56 is equal to 1.8 T. Then we need to divide both sides by 1.8. So that gives us 56 divided by 1.8, which is 31. So the temperature is 31 degrees Celsius. Graphing. Steps for plotting the data in Table 2-14. Select a linear plot. Choose scales based on the data. Number the major axes. Label the x and y axes, including units. Plot the data points, draw a smooth curve, and then title the graph. So here we're going to have volts on the y-axis, time is on the x-axis. It's voltage versus time for an electrical component after the switch is closed. The vertical axis is in volts, the horizontal axis is in seconds. Error. Error is the difference between the true or best accepted value of some quantity and is a measured value. Accuracy is the difference between the measured value and the accepted or true value of a measurement. Precision is a measure of the repeatability or consistency of a series of data points. Variable is a quantity that changes, and constant is a quantity that never changes. Coefficient is a number written in front of a term. Expression is one or more terms. Equation is a mathematical statement that sets one expression or quantity equal to another. Independent variable is a variable that is controlled or changed to observe the effect of another variable, and a dependent variable is a variable that is influenced by changes in another variable. Here's the quiz. In engineering notation, the number 0.00056 is written as A, 5.6 times 10 to the 4th, B, 5.6 times 10 to the minus 4th, C, 56 times 10 to the minus 5, and 560 times 10 to the minus 6. The key here is engineering notation, so you're looking for a power of multiple of 3. The number 2700 megawatts, the capital M is a mega or 1 million, can be written as 2.7 terawatts, 2.7 gigawatts, 2.7 kilowatts, 2.7 milliwatts. The sum of 33 milliwatts plus 1.5 watts is 331.5 milliwatts, 335 watts, 1.533 watts, or D, 1.83 watts. So what you have to do for this one is convert the 333 to regular number, which is 0.330, and then add 1.5 to that. Let me fix that. That's the math that you're doing. A supplementary unit defined in the SI system is the ampere, coulomb, radian, or watt. 1 joule per second is the same as 1 watt, 1 coulomb, 1 ampere, or 1 volt. An example of a derived unit is the second, volt, ampere, or kilogram. The number of significant digits in the number 0.03030 is 2, 3, 4, or 5. The equation for converting degrees Fahrenheit to degrees Celsius is degrees Celsius is equal to 5/9 times degrees Fahrenheit minus 32. The Celsius temperature that corresponds to 80 degrees Fahrenheit is, so all you need to do is put 80 degrees in for Fahrenheit. So you're going to have 80 minus 32, then multiply that by 5, and then divide by 9. The gain equation for a certain amplifier is AV, which is gain, is equal to 1 plus R2 over R1, so resistor 2 over resistor 1, where AV is the gain, R2 and R1 are resistors. If the gain is approximately 40, when R1 is 5.6, what is R2? So here we're going to have 40 is equal to 1 plus R2 over 5600. So what I need to do is subtract 1, so that gives me 39 is equal to R2 over 5600, and then multiply both sides by 5600, so you get 39 times 5600, that equals R2. 10. When plotting a graph, it is important to A. Plot the independent variable along the y-axis, connect the data points dot to dot, label the graph all of the above. And the answers are as follows. 1 is D, 2 is B, 3 is D, 4 is C, 5 is A, 6 is B, 7 is C, 8 is A, 9 is D, 10 is C.